Hi, my name is Daniel Otamelum, and this is my ISP, Keep Talking and Nobody ACESplodes. This project is a combination of 4 individual bomb defusal minigames, each based on the real game Keep Talking and Nobody Explodes. This uses the Arduino Nano and standalone ATmega 328P as my microcontrollers of choice due to their compact size, high number of GPIO pins, and their use of I2C communication. I2C communication is a protocol that allows multiple devices to exchange data over just 2 wires: SDA, serial data for data transfer, and SCL, serial clock for synchronization. One device acts as the master, and the others act as slaves. Each slave device has a unique address, allowing the master to communicate with specific devices by sending data to their addresses. I2C is commonly used in contain modules to allow the master Arduino to send commands or receive information from the slave modules, helping to control the game logic and module behavior efficiently. An example would be if I had multiple modules. This means that a module, even if powered, will not turn on and will not start running until the master sends a signal. Only then will the module start running and the game can begin. To achieve this behavior, I use the handler function. This function is responsible for all I2C communication between the master and slave modules. It constantly checks for any incoming requests from the master device and responds with specific outputs based on what the requests were, or by sending out strikes, module completions, and game parameters. When it comes to actually running the modules, there are 3 important functions or statements that I use: the random function, the switch case function, and the structs. The random function creates a random value with a certain range, which made each module run differently each time it was played. Combine this with analog reading an unused pin, for example, a 0 meant that the game would be truly random, since the code will cause the reading of stray voltage. An example of this, we have the Simon game. Each time I restart the game, it will start with a different sequence. There it started with yellow, now it starts with blue. Next time, it starts with green. The switch case statement is a useful technique that allows the user to handle multiple conditions more efficiently than an if-else ladder. Instead of checking each condition one by one, switch case statements jump directly to the matching case based on the value of a variable. For example, in the Simon module's light-up button function, this can be seen when the switch case checks the color of the variable, and based on its randomly generated value from 0 to 3, it assigns the correct LED pin to the LED variable. The flash LED function then takes this value and uses it to flash the corresponding colored LED, giving us the sequence playing. The last important technique I used during this ISP was structs. Structs allow the user to create custom data types that group related variables together, making the code more organized and easier to understand. For example, in Morse code, there are 2 structs, one for the Morse alphabet and one for the randomly chosen word and its corresponding frequency that needs to be inputted. By using structs, both the Morse letter and the word with their frequencies could be stored efficiently in arrays, using pointers to easily search and display them during the game. When the module selects a word to display in Morse code, the program loops through each letter in the word and searches for its corresponding Morse code sequence stored within the Morse alphabet array of the Morse letter struct. Once the correct sequence is found, another loop processes each symbol in that sequence. The chosen word is then displayed in Morse by finding the first letter of the chosen word, searching the Morse alphabet array for how to display the given letter, flashing that letter in its dots and dashes, pausing to show that the letter is finished, then moving to the next letter and repeating the pattern until the word is spelled. My name is Daniel Otamelum. Thank you for listening to my ISP.